Chloride pollution is a major concern in freshwater ecosystems because it raises the salinity of the water, where many organisms cannot handle these changes and can be highly toxic in large amounts. Once chloride is in the water, we do not have any successful way to remove it once it's in the environment. Chloride, like road salts, enters our streams and rivers through stormwater drains you may have seen on the side of the road. This water is not treated before entering waterways, so anything that was on the road is now being flushed into that freshwater system. Currently, there is no biological indicator for freshwater systems that can be used to identify areas with high chloride levels. In snowy climates, water bodies receive many forms of chloride such as road salts, fertilizers, and year-round water softener pollution. Our findings demonstrate halophilic populations are widespread and permanent members in the sediment at all of our study sites located in a Lake Michigan drainage basin. Halophilic is a halophilic family. Halophiles are extreme bacteria that are traditionally known to require the presence of salt to survive, such as our oceans, which make them an attractive candidate in determining chloride-impaired areas. A total of 94 isolates were collected and characterized by salt concentration and temperature preference in laboratory-controlled experiments. Isolates tested at 5 degrees Celsius, a cold temperature, favored 2% salt, equivalent to a chloride concentration of 12,000 milligrams per liter. At 18 degrees Celsius, a warm temperature, isolates shifted to a preferred salt concentration of 6% salt, which is equivalent to a chloride concentration around 36,000 milligrams per liter. To put these concentrations into perspective, our oceans are about 20,000 milligrams per liter. Sediment was plated onto nutrient media containing 6% NaCl. Because this is extremely salty, anything growing on these plates will either be halophiles or salt-tolerant bacteria present in the sample. Our results found higher colony-forming units at our urban sites during the winter and spring when we compared it to our rural sites. We also created an assay to specifically target the halophiles, where we found halophilic populations remained stable throughout seasons. These populations did not follow instantaneous chloride values as much as our colony-forming unit counts, but rather suggest these halophiles could be used as a long-term measurement for chloride-impaired areas to understand baseline populations in southeastern Wisconsin. Using halophiles as biological indicators, our research aims to assess chloride pollution in a Lake Michigan drainage basin to better understand the long-term ecological impacts as we continue to salinize freshwater resources.